everybody, and welcome to this conversation on social entrepreneurship and innovation as a response to the current pandemic. We're going to be talking about a startup that Professor Gaurav Giri, aka Gino, and myself launched about a year and a half ago on air filtration. And specifically, we're going to talk about some of the pivots that we made in the last few weeks on how the air filtration startup is addressing the current pandemic. So as a roadmap to the presentation, we're going to start with a quick technology overview of what the air filtration startup is about. We're then going to talk about the innovation and the application areas, then the business model, and finally some ways that we're looking to scale up. And we'll talk for about 10 minutes and then leave majority time for Q&A. With that said, I'll ask Professor Gino to take it from here.
Thank you, Bala. So before starting, I'd like to say that if you do have questions, please put the questions down in the Q&A section. We'll curate it and look through the questions and answer any that you might have. So I want to first begin just talking about what the technology that we've developed here is and a little bit about my background, right? So I'm originally from Nepal, a country which is very beautiful, but over the last couple of decades, the air pollution has become worse and worse. So Kathmandu, the capital city, now is known as like around the air pollution of like a top 10 in terms of the worst polluters or the worst polluted cities in the world. So the idea behind us starting this air filtration company was to just use the technology that we have developed to able to actually see exactly how we can help air pollution as a problem, right? So the technology that me and my lab are working with in the University of Virginia in the Department of Chemical Engineering is known as metal organic frameworks. Now, what metal organic frameworks are like, sorry, my cat would like to go outside, but she can't yet. But the idea is that for metal organic frameworks, they are nano cages. So they're very periodic. You can make them really thin films, but they are small enough so that air can pass through. So oxygen can go in, water can go in, carbon dioxide can go out. But the cages are so small that any particles can't pass through, right? So the idea behind this, when we first started, was, hey, look, if we take these moths and we can put it in a low-cost fabric like cotton, bamboo, hemp fibers that are commonly used in the developing countries, we can then start making low-cost air filters. The process we have developed that we have a patent on is that we can make this extremely fast and large scale compared to what traditional methods of making moths are. So now that we can make an effective filter that can be made in large scale and that can be made cheaply on multiple different types of fabrics, we can now think about using this as a massive widespread air filter technique that many people in the developing world can use. So air pollution is a big problem generally in the developing countries, so such as China, India, Nepal. So that's the original idea that we had on using the technology to benefit society, right? So we started a company about a year ago and we have been working on that. On the tech side, at least, the number that people generally look at is N95 efficiency, which generally means how efficient your mask is to filter out these particles. Our moth filters right now are on the level of around N90 efficiency, right? So what that means is it filters out 90% of the PM2.5 particles. So that was the current state of the technology up to a month ago. And as a company, our first goal was to get N95 performance so that we can say our material is as good as the best out there and it can be made very cheaply and on fabric. With the quarantine, with COVID-19 and everything, we have decided to pivot because we can help people better by using the same technology, but for the more proximal problem of viral transmission. Just like I said, these moth films in fabrics are useful to stop air pollutant particles. They are just as useful to stop viral particles. So viral transmission can occur in one of two ways. One is you cough out and there are droplets. So they are the size of like 10 to 50 microns in size. Our moths are good enough to stop that. And more importantly, the small virus itself is around 0.1 microns in size. And that is the current research we're doing to see, can we actually get stopping of those particles to the level of N95 filters. So that is our current goal on the tech side of it. But as I said, even if it's not N95, it is still good enough that it's much better than the current recommendation in the current climate. So for example, the CDC has come up with recommendations that because masks are running out all over the country, it is actually better for you to use a cotton t-shirt and fashion a mask out of it to put it on your face before going outside. The efficiency of cotton filters, we have tested this in labs, around 4 to 14%. It's not good. So our idea is, look, our material is much, much better than what is the current recommendation. So therefore, we should be able to take our company and produce these things in mass scale so that we can currently help the pandemic. And over the long term, while the pandemic may die down, air filtration will still be an issue, either for pollution or for pandemic recurrence. And then we can start utilizing these materials for the long-term effects and impact as well. All right, Bala.
Yeah, perfect. Thank you. So just for context, in terms of brand positioning, think of us as the Gore-Tex model for air filtration, right? So just as Gore-Tex creates materials which are breathable and waterproof and sells them to other apparel companies, we believe that we can do the same by selling breathable and air filtration materials to textile manufacturers who may want to integrate this material into their product lines. So that has been a fundamental pivot we've made, because initially we actually wanted to create the entire product on our own. And now with this pivot, we are more of a business to business, where we just want to focus on what the technology is good at in providing air filtration, and then working with existing textile manufacturers to help scale that up. So that's one. And two, we're also working with the metal organic framework technology, which has the potential to do more than just air filtration. It can actually also stop viruses. So on the one level, we are working on air filtration products. And on another level, we're also working on being sort of an R&D company, where there's going to be more and more research done on these different air filtration technologies itself using metal organic frameworks. And also, just as for Gore-Tex, right? I mean, they did not know who their first customer was. The first customer for Gore-Tex actually was a really unknown tent company in Oregon. So similarly, we really don't know who will be the first purchaser of our fabric. So at this point, we're looking to ship out samples of the fabric to a range of different companies. And depending on how the companies like it, they can give us a purchase order to actually mass manufacture it for them. So that's where we are. There's also, of course, the possibility of sub-licensing this technology to a bigger company and working with them, especially considering the urgency right now to get this technology out. We think that even working with a bigger company and quote unquote giving away the secret sauce, but still getting the technology out in the market may be very beneficial. So we don't want to, hold on to this technology, and we really want to try to get it to society as soon as possible. So we're also open to the possibility of sub-licensing it and helping with the transfer of know-how. So that's the two ways we plan to proceed going forward. Gina, do you want to talk anything about the technological challenges?
So yeah, the biggest challenge right now that we have is all of the work we've done is in lab scale. So lab scale generally means the processes we have developed should be applicable to to large scale industries, right? So we have used water as a solvent, for example, so it shouldn't have to use any of the dangerous stuff. We have made the technique fast enough that you can do it in a large scale manufacturing facility. But the question is always going to be, does it actually do that, right? So the first the technical challenge that we want to solve is in engineering called the problem of scale up, where yes, we can make individual mass size fabrics right now, but how do we actually get the conditions down that we can make this in thousands of square yards? So you 1,000 square yards of cotton in a roll, you unroll that, pass it through the material that actually gets the moth inside the fabric, and then roll it up on the other side, right? So this is known as roll-to-roll coating manufacturing. This is exactly how they use textile coloring right now, for example. So we believe we can use the same technology because we're using the same technology in the lab. But again, scaling that up to actual production is the first step that we want to hit. So on the technical end of it, the main thing we're trying to do is collaborate with textile manufacturers so that either we can get the equipment here so that we can do it ourselves, or we can borrow time with manufacturing industries so that we can go to their site, figure out the process to know how to get it done correctly, and then actually give them the secret sauce for either sub-licensing or as a partnership, whichever business model we choose is best. That's one side of it. That's the technical side of it that gets the product out ASAP. The second side of it, of course, as I said, is actually getting the filtration up to N95 levels, which means we can then get it certified through NIOSH and the national agencies, which then allows us to actually put that stamp on saying, we know it is this good, and that it can be used for multiple other things than just consumer product. It can be used for, let's say, medical purposes. It can be used for occupational work and so on and so forth.
Mm-hmm. Yeah, so the core advantage of this technology is that because we are fabric based, we're not bound to making another mask, another clunky, stiff mask. In fact, the main advantage may be to create a scarf or a bandana or a hijab or baby stroller covers or curtains, right? So there could be several different applications of this material in very different product lines. So that's the key advantage, is that we don't have to be a clunky mask. And as we all know, as the demand for this increases, so will the fashion. So it's very likely that designer scarf companies will want to have a competitive advantage by also having an air filtration capability inbuilt in them. So we're really hoping to partner with some of these companies and provide that capability to their existing technology.
Yep.
I'm keeping a tab on the time. It's around 11:12, so we have 18 minutes. So I think that's a good time to have some QA. And I already see many questions here, which is terrific. I'm going to read them out, and either Gino and I will help answer that. So the first question from Ian Baxter: what are some of the immediate next steps that you're taking to bring the technology to market? So I'll take that. The first step we're actually doing, considering the urgency of the situation, is we've been very lucky to actually connect with a local person here who's actually hand sewing masks at her house to help address the shortage. And she has very kindly offered to give us about 5 or 6 masks and with an insert. And in that insert, we're actually going to put our fabric and test it out, and also maybe put a logo and use it ourselves, right? Because I guess the proof is, if we actually use it ourselves and walk out, we will get some visibility. But also, we want to give this to friends and family and as a way to test out. So that's our first step, and we believe that that's the really entrepreneurial step to get to market, is to have a minimum viable product, and that will be it. And in many ways, this pandemic really expedited this whole process, right? We were looking to be perfect in many ways, and as we all know, perfect may be the enemy of the good. So we believe that instead of waiting for things to be perfect, now we're just going to go with what we have. And we've just been very, very lucky to meet with some incredible people in the community who's going to help us to take this forward. Mm-hmm. Next question from Ashley Conley. How do you combine MOF materials with the fabric such that it is mechanically stable / particles are not able to be breathed in by the user?
So full disclosure, Ashley is a graduate student in my group. So the question is pretty specific and pertaining to our current research, right? So Ashley, the question is perfectly right. Let's how do you make sure that, because we're trying to make these thin films and the MOFs are pretty tiny to begin with, that the MOFs don't get breathed in by the user? So we're answering this in 2 ways. One, the rapid formation of the MOFs occurs because the MOFs, actually the reagents that make the MOFs, go inside the fabric. So I think that it's actually bound within the network of the fabric and not just in between individual fabrics of cotton. So because of that, we have already shown that it is much better mechanically than most of the loose powder on fabrics that most other people make. So for those of you who know what sonication is, it is a very high-powered way of vibrating the fabric to see what actually stays on the fabric and comes out. We have tested our MOF fabrics with after sonication and still shows the same level of efficacy. as before sonication. So that is a good way of seeing whether or not the MOFs are actually coming out of the fabric. Because if it was coming out, you'd lose a lot of that filtration efficacy. So, but that's a great question, especially if we want to claim that it's reusable. You then want to run it through the same washing drying cycles that most people run through, any wash and dry at our home. So that's something we're planning on doing as well, where it's like, look, we've made a MOF fabric. Let's run it through the washer dryer combine for 10, 100 cycles and see what the filtration efficacy looks at the other end of it. So that's part one. The second part is the MOF stability can be tuned chemically. So what we are trying to do, what we can do very easily is we can make MOFs such that they degrade in the lung atmosphere. So high humidity, decently okay temperature. So the idea is that if the particles ever go into the lungs, they disperse back into their original reagents, and the original reagents are both FDA safe. So that's not going to be a concern either. But yeah, that is a great question.
Thank you, Gino. Next question by Riley Kinley, who's actually my student in the emerging markets class that I'm teaching this semester. Good question, Riley. Do we have a patent pending? Is this technology patent pending? Gino, you wanna?
Yeah, so the patent actually came through where the original inventors on the patent are me and my graduate student, Luke Hulsenbeck. So currently, through the efforts of us and UVA's LVG, we have had the patent going through. So we got the provisional, we converted that to a full international patent. And right now that full patent application is pending. We expect to hear back in the next 4 to 6 months to see if they have any concerns, to see if there are any issues that they're going to have. So the idea is that, yes, it is patent pending. The reason we're able to share all of this is because it's patent pending. The other side of it is that our company, Hava, is in the final stages of exclusively licensing the patent so that we're the only people who can at least get the technology out into the world, because as inventors, we do get the first right of refusal. So we can't say, look, I want to start a company based on this technology because I believe in it, right? So that's the licensing agreement that we have with UVA.
Great. And also by Riley, how is Hava still planning on creating clothing items with this fabric and not just masks? That's another great question, Riley. We actually, we believe the opportunity may actually be not in masks in some ways, but in scarves or bandanas. And if you see the CDC recommendation recently, they're basically people just wearing, clothing, T-shirts as bandanas on themselves, right? And there's really no air filtration there. So we believe that the opportunity is huge in other clothing items, especially. So we're aggressively following that. And also, in some ways, we don't want to reinvent the wheel by creating another mask. The mask industry is already quite saturated, but not the fashion apparel industry. So that's the industry we think is the bigger opportunity. Next question, why should companies like 3M and others pay attention to the Hava technology? Gina, you wanna?
Yeah, so there are a couple of ways of answering this question. I think starting from the technical details of it, right? I will say that the biggest achievement we have done with the patent is that most people have shown that MOFs can be used for many, many different reasons. You can use it for filtration, you can use it for water desalination, you can use it for charge transport, you can use it for batteries, you can use it for solar cells, catalysts, what have you. So the application space of MOFs is humongous. But although the MOFs have been around for 20 years, there have only been 8 to 10 companies that have commercialized MOFs. And some of the reason for that is that it's very, very difficult to produce it rapidly. Most MOFs are made on a time scale of hours to days. And for most technical companies, that's too slow. The amount of control you can have in the system is too slow when the reactions occur that slowly. So because now we can make it rapidly, and when I say rapidly, I mean the entire reaction is done in seconds compared to hours, right? So because we can do it that fastly, now actually scaling it up to high production, like large scale production, high throughput production, and really cool MOF plus something else. So for example, MOF plus fabric or MOF plus plastic, these sort of technologies become possible. So yes, we are starting our main thing with air filtration, sorry, our first product for air filtration, but we believe that the HAVA technology can be useful in the mid to late long-term future for a wide variety of technologies that MOFs have been able to show.
Mm-hmm. And also, it's a very disruptive technology, right?
It is, yes.
It's a newer technology. It's a lot more disruptive, and especially big companies like 3M, from an innovation perspective, should pay attention to these smaller technologies, which could really scale up fast. So it would be in the best interest to really pay close attention to what's happening in the metal organic framework world. Next question, what are some of the ways in which we can support your efforts? Well, I will, both Gino and I will put our email addresses in the chat box after, so all of you have access to it. One way would be to just contact us for more details on the company. And if you have recommendations on companies we could contact to work with, or local manufacturers who may be interested in using the technology, that would be terrific. So yeah, so we'll send you our contact for that. What companies do you think would benefit most or be the most open to your HAVA technology? Who do you hope they would be? Gina?
So I think there are, again, two ways to answer this. On the technical side of it, I think any material science company would love to have the ability to do what we do. Because as long as you want to create new products, novel designs with novel applications, then you really, or at least using MOFs, you really want our technology being able to do that really, really quickly and be able to convert it to an industrial scale, right? If you can't mass produce it, then it's still only a research problem. It is not a solution to problems that the society is facing right now. So any companies, so for example, like we talked about in the last question, like 3M, BASF. So these are, huge chemical or material science companies. These would be the right people who would like the technology for the sake of the technology itself. On the other hand of it, the product that we're making, the MOF fabrics, would be a great value add for any company that wants to position itself as different than anybody else out there. As Bala said, we are literally the only people out there who can make MOF fabrics in this sort of large scale that is amenable to industrial processing. Given that, any fabric company that wants to advertise saying, look, we can actually make clothes for you that prevent viruses at some percentage of efficiency much better than cotton, is a company that would love to talk to us to get access to this technology.
Perfect. Question from Prince Verma. How fast can you make this MOF fabric composite? How well do you scale up the process?
Beautiful question, Prince. Again, full disclosure, Prince is also a student in my group. I swear to God, I did not plant these questions. Right? I'm just happy they're actually here to talk about this. So, Prince, the fastest we've been able to make the MOFs is second timescales. I'm pretty sure we can get it to sub-second timescales if we really need to, but within seconds, it matches the speed of roll-to-roll coding that people currently do in the fabric industry. So there is no reason to go faster, at least the way I see it right now. So the technology we have right now is good enough for the current technology that people use in the fabric industry. So that's part one. The second part, which is how will you scale up the process? The idea is that the rapid speed and the solution processing is exactly what they do in the textile manufacturing industry to coat your cotton, your white cotton fabric to, let's say, a blue or a yellow or a brown cotton fabric. That dyeing process of putting it in a solution with a color and then drying out the solution is exactly what we need to do to coat it with MOFs too. So because that is the initial technology we've made in lab scale, even though we haven't scaled up the process, the chemical engineering principles are going to be similar enough that the only thing we need to figure out is how to do it, not if it can be done.
Next question. How might you rapidly get on the radar of print-on-demand clothing companies, aka drop shippers, to roll out your better than cotton product at a mass scale? Well, we have been contacting 3D printing companies And especially with the current pandemic, there are several companies now basically 3D printing masks. So we've been talking to a few of them to see if there's a way to insert our mock fabric in that mask. So that's one way. Other than that, we haven't. We're still looking for contacts in the general print-on-demand space. So if you have any, that would be highly appreciated. Mm-hmm. Kyle asked a question on: are you open to collaboration with other startups? Also, have you considered SBIR funding or ICOR? Gino?
Yeah, so I can take that. Yes, we're of course open to collaboration with other startups, especially if the addition of two technologies can provide even a higher value add, that our combined products becomes even better. That is going to be a win-win for everybody involved, right? So that's one part. We are currently looking more towards the manufacturers who can help us scale up, and generally they are the more established companies who at least have a manufacturing facility. But that doesn't preclude the use of startups to do that as well. That is our reason. Actually, doing that is the reason why we're asking for funding. Is that, look, if there is either we're going to find a manufacturer fast enough to scale up there, or we just buy the equipment ourselves so we can do it here. In either case, having a startup to be able to do that will make it even better. Actually, yes, we have, my student and the co-founder, Luke, did do ICOR last year. So yes, it was a great way of actually focusing the company to understand what the consumer actually needs. How do you design a product that's based on consumer demand, right? And this is the year that we are heavily looking into SBIR funding and SBA loans, where the idea is the government will also help us get in a non-dilutive way of getting our company making these products in a large manufacturing scale.
Once the COVID pandemic has passed, do you plan to still concentrate on domestic markets? That's a really good question. Yeah. Honestly, when Gino and I first launched this company, a big motivation for us was to help people in the emerging parts of the world. I'm originally from India, Gino from Nepal, and we've had the opportunity to get educated in the US and have this, be at UVA, and we believe that a way to give back was to use our skill sets in addressing a problem which is really big in Asia. That being said, if you see what's happened recently, now the problem is right here at home too, right? It's really a global problem. So we don't think it's going to be this dichotomy between domestic and international. We just want to build a good product that can be used by anyone, anywhere in the world. But we're definitely now focusing more of our efforts on the local market because the need here is huge, right? It's perhaps even bigger than some parts of Asia in terms of the response to this pandemic. So the need here is huge. So we are definitely focusing most efforts to help address the local shortages in Charlottesville and Virginia. Gino, do you have anything else?
No, that sounds good actually. Sorry, I was just looking at the next questions.
Great. Next question, Thomas, how will UVA's LVG help you in your team's goal to scale? So the LVG group has been very helpful so far in terms of filing a patent and giving us really good contact recommendations and working with us in ways to get the technology forward. So it's been a very good experience, and we will be talking with them further on ways we can even take this further. That being said, we've also been working with several external advisors on that question. So. How are you fundraising? Is there a fundraising link we can share with our contacts? We did run an Indiegogo crowdfunding campaign about a year ago, which was really powerful, especially as academics, for us to go out there and raise capital on our own was huge. So we're doing that. Well, we did that. Most of the capital we have raised so far, actually all the capital we have raised so far is non-diluted funds through research grants. So we have not included an investor yet. But that being said, we're still looking to fundraise. So in our deck, we are looking to raise $250,000 in return for about 10% equity. And if anyone's interested, we can talk more details on that. I will give you my email address. And we don't have a fundraising link at the moment, but please contact us if you're interested to be part of this effort and help out, and we would love to figure a way to work together.
Yep. All right. So I believe that is our time.
About 11:30. So
Yeah.
thank you, everyone.
Everybody. Yep.